Alright, we're going to look at this fraction and rationalizing the denominator. In this particular fraction, we have an entire expression as our denominator with a radical 2 here. To get a rational denominator here, we're going to have to multiply this by its conjugate, which means this sign in between here is going to have to be switched to a positive, and we're going to keep this term and this term the same and multiply through. So we multiply by the square root of 2 plus x, and we have to do that in the numerator as well so that these are equivalent fractions. And this ends up being a double distribution process. So we have square root 2 times square root 2 is going to be 2. The square root of 2 times x is going to be positive x square root 2. Negative x times square root of 2 is negative x square root 2. Negative x times positive x is negative x squared. In the numerator, we have 2x times square root of 2. And then we have 2x times x is 2x squared. In the denominator, we don't have to worry about the square roots that showed up here because we have positive and negative versions of the same term, and so they are going to 0 and have canceled each other out. So we have 2 minus x squared left in our denominator. We have 2x square root of 2 plus 2x squared in the numerator. Alright, we have this left as our fraction. This is an improper fraction. If we compare the degree of this expression to the degree of this expression, we see they have degree 2, both numerator and denominator. So this is reducible. You can divide a factor out of here and rewrite this if that's what's necessary. If not, you can stop at this point. But if you want this to be divided out, you're going to end up with negative 2 plus 2x square root of 2 plus 4 over the original denominator here, and that's as far as you can reduce this. So this is if you want something in mixed form, and this is in proper form. Either way, we have rational denominators at this point, and so we're good.